So in the next couple of videos, we're going to look at the properties of rational exponents. Rational means a ratio, like with a ratio like fractions. So we're going to look at properties of exponents, and we're going to see what they look like when we have fractions as exponents. I'm first going to just write down a bunch of rules, a bunch of properties, and then we'll go forth and do some examples. The first one we've already known, we've used it many times before, and it's when you have the same base with different exponents, actually the same exponents as well. If you have the same base, this is called the base, this is called the exponent, you add the two exponents, so that we have that. Something really simple. And then we also have, well, I'm just going to write down all of them and then I'll explain them each individually. So here we go. If we have a to the m and then raised to the n, that's a power of powers, we simply multiply the two powers together. And we write the base once, a to the mn, just like that. If we have two things inside parentheses, raised to an exponent here, then all we do is use that exponent on everything on the inside. Now this only works if there's multiplication or division inside here. It does not work if there's addition or subtraction. So that's something to be careful about. So that's the rule there. This just goes on the inside to each one of those. When you have a negative exponent, you can turn it into a fraction, 1 over something, just like that. If you have an exponent of 0, that doesn't matter what this is as long as it's not 0. But why would you write 0 to the 0 anyway, unless you're thinking about calculus? So we won't have to worry about that. But anything to the 0 power is going to equal 1. Simple as that. So if it was 8 to the 0, that's 1. If it's x to the 0, that's 1. No matter what it is, it always changes to 1. That one's something to remember. It's just a property that you have to remember. Then what else do we have? We have a to the m divided by a to the n. When these are the same, this rule is kind of like similar to this one. If you multiply with the same bases, we're multiplying with the same bases. You add the exponents here, we're dividing with the same bases, so we subtract the exponents. Then you write the base one time. And then this rule is similar to this one, so we'll just put the exponent on each one of those things. And there you go. Those are the exponent rules. It's very simple. So, example 1, we're going to simply figure out what rules we're allowed to use. This one, it says to simplify, and I'm going to use this rule. Why? Why am I going to use the rule? Because I have the same base here, the same base. So I'll just add the exponents. So I have to get a common denominator. So here I'm going to have, let's do it in green, 7 and 1 to the 1/4 plus 1/2. Remember, I write the the base once and I add the exponents. I will need to get a common denominator. So then I just get 7 to the 1/4 plus 2/4. That's just 7 to the 3/4. You can do all of that in your head. I don't mind if you do that in your head. I'm just showing you all the steps. In fact, I'll try and do this one in my head. Which one? I think it's this one, right? That's the one I'm going to use. I don't have addition or subtraction, so that's okay to use that rule. And this will just go to each. 2 times 1/2, that's just 2 over 2. That's just 1. And 2 times 1/3, that's just 2 over 3. So times 4 to the 2 over 3. Now some people are thinking, oh, let's multiply 6 and 4. But you can't do that because this is not actually 4. It's 4 to the 2/3. We already saw yesterday or the day before, whenever you're watching this, we already saw previously that 4 to the 2/3 you can put into the calculator and it's some decimal number. So we can't go 6 times 4 because this is not actually 4. It's 4 to the 2/3. It's a completely different number. So you got to be careful with that. And then I can't simplify anymore. That's all I can do. So that's that one. That one's easy. This one, there's two things I could do. I could like move the exponent in like I did there because there is no addition or subtraction. But I have a negative exponent, so I'm going to use this, where is it? This rule. When I have a negative exponent, I can make a fraction. So this would be 1 over, and then just repeat everything. Now it's a positive 1/5. And then now I'll put that in. So I get 1 over, well, 1/5 times 5 is 1. And 3 to the 1/5 times, okay, so 1/5 times 5, that's also 1. So 3 to the 1. Now I can actually multiply 4 times 3 because, well, this is actually 4 and this is actually 3. Whereas here, this was actually 6, but this was not 4. It's something completely different. So this one's actually 1/12. Sweet. And then the last one, let's see. We have, well, I guess when there is no exponent, it's just a 1. It's not a 0. If we had a 0 exponent, that would correspond to that rule, but we don't have that. So well, I can subtract. Where is it? This one. I can subtract the exponents because I have the same base. So I'll do that. I'll write the base once, and then I have 1 minus 1/3. I can put this over 1 and get a common denominator. Times 3 times 3. That would be 5 raised to the 3 over 3 minus 1/3. That's just 2 over 3. Again, you can do that in your head. I don't mind if you do that in your head. I feel it will feel easier if you do it in your head. Okay. Well, we were doing this in class, and I think the first thing that people think of is move this exponent inside, so multiply. So that's fine. Let's do that. I like that idea. So we have 42 raised to the 2/3 divided by 6 raised to the 2/3 again. Now, this is what people didn't understand. To finish this, we have to use one of the rules backwards. We have to actually use this rule and go backwards that way. And in fact, all of these rules we can go backwards if we wanted to. So just make sure that you know these rules go forwards and backwards. So on this one, those are both the same. So we can actually write 42 divided by 6, parentheses, 2/3. And if I distributed that in there, then yeah, it would be the same thing. So I just use that rule backwards. And like, what was the point of that? Well, now I can actually do 42 divided by 6. That's just 7. So it simplifies a little bit. 2/3, and that's it. There we go. I'm going to be done with this video. Yeah, and we'll move on.